Today's video is on soil water. You might be wondering why I'm in a kitchen, but the principles of soil water can be easily shown using common household items. The main concept of soil water is capillary rise. Capillary action comprises of two different forces. There's adhesion and cohesion. Adhesion is the attraction of water to other particles, such as soil particles, where cohesion is the attraction of water molecules to other water molecules. We can easily demonstrate capillary rise and adhesion and cohesion using paper towel. This demonstration shows what happens when you stick a dry paper towel into a dish of water. You can see that water rapidly enters the paper towel. It gets wet quite quickly, but as time goes on, the speed that the paper towel gets wet slows down. That's because in the initial stages, water is flowing up very large pores as well as small pores, and it enters those very large pores very, very rapidly, and so the paper towel fills up quite quickly at the bottom. As time goes on, water is not flowing into those large pores anymore. It's only going through the very small pores, and because the pores are so much smaller, it takes more time for the water to flow through. There's more resistance to flow. The water will flow into those pores quite easily, but flowing through the pores, small pores, takes more time. And so you can see that the paper towel has been filled up maybe 5 centimeters at this point, and so it is, and the wetting has slowed down quite significantly. In a soil, clay soils have very small pores, and so they hold lots of water because the water doesn't like to leave those small pores, but it takes a long time to get wet and for water to flow through a clay soil because the pores are so small. There's a lot of resistance to flow. Sandy soils, on the other hand, don't hold much water because the pores are quite large, and large pores don't hold water very well, and so the water will drain out of those pores very easily, and sand soils get wet and they dry out fairly quickly because water flow is much more rapid through the larger pores in a sandy soil. In this demonstration, as I dip my fingers into the water, you can see that my fingers are getting wet. That's not a surprise, but when I put my fingers together and then pull them apart, you can see a bridge of water between my thumb and my index finger. That bridge of water is illustrating adhesion and cohesion. Adhesion is when the water is sticking to my fingers, and cohesion is when the water is sticking to other water molecules, forming the bridge. As I move far enough apart, as my fingers go far enough apart, the bridge breaks. That indicates that the water will drain out of that pore. So in summary, water is held in soil with a combination of adhesion and cohesion forces. The adhesion sticks water molecules to soil particles, and the cohesion will stick water molecules to other water molecules. This is what helps water stay in soil, as well as what helps water move through pores in a soil through capillary action.